SuperDuper database. SuperDuperDB? It sounds like a database because the DB suffix is there. The database, it's in the name, but it's not a database. What we do is we bring AI to our databases or to our data. It's a nice way to bring data from existing data pools like databases and files and other things directly into your workflows. They make it really easy to add AI capabilities on existing data sources. It's pretty exciting. They offer basically most of the most common database kinds and varieties. We've got Postgres and Mongo and SQLite, probably MySQL in there, Databricks. I saw a Snowflake in there. Oh, there it is, as a Snowflake as well. Yeah, it looks like we can do quite a bit. I like this code example here. It's not a full example, obviously, though it gives us like a nice little entry point. We use Mongo database. We give SuperDuper our Mongo client, and then we can run a similarity search. SuperDuperDB. This sounds like a really powerful database, but what it does is actually pretty amazing. On top of that, one of the benefits of, you probably heard vector databases, or the ability to do similarity searches off of any kind of data. Usually in databases like Mongo and Postgres, you'll have text-based data. And so what you can do is you can use SuperDuperDB to create a nice path into your existing data to leverage vector search. And the cool part is you don't need to have a separate database in order to make that possible. You can use your existing database, which is fantastic because now it reduces our footprint altogether. If we really wanted to add vector search capabilities, now we can just use SuperDuperDB. So some quick pseudo code here. They're giving us an example of importing various SuperDuper modules, and then we don't know what DB is, but must be defined higher up. We can add a vector index to our existing database. When adding an index, we can use any sort of embedding. It looks like we are, in this case, are using OpenAI's Ada 2. We could bring in any other kind of embedding as well, even DIY, but you probably grab one from Hugging Face and something like that as well, so you don't have to pay extra from API call perspective, especially if you have a lot of data in your database, so you don't want to have to vectorize every single row, and maybe if you have 1 billion rows, this could cost hundreds of dollars really quickly. With SuperDuperDB library, we can turn all of our existing databases into fully functioning vector databases, and you can do a lot of things with that, such as vector search, but you can go a step further, and if you've already created all the embeddings that are stored in that database, you can use those embeddings to train models. This is really powerful because when you're training a model, you don't want to have to also create the embeddings at the same time. Usually the embeddings are going to be fairly static once you've generated them. So you don't want to have to regenerate the embeddings over and over and over because that could get expensive. So you would want to just generate the embeddings once, store those, and then leverage them directly when you're training a model. So we can use something with like PyTorch here. See, it looks like we can import SuperDuper, and then we get a transformer pipelines, something very simple and clean. We're going to do Cinnamon analysis. All right, and then we call model.fit, which is a common PyTorch method. This will do the model training, which is going to be like the machine learning part. Then you've got the prediction, which is going to do something. It's going to do a thing. It's going to predict whatever we train the model on. I like this because it helps simplify my code. Often I find when I'm doing AI training and AI models that my Python notebooks or my Python code in general get really busy really quick because AI has a lot of steps built in. One of the great parts of using SuperDB is it's going to reduce that code footprint altogether. Now I can do more experiments more quickly. I can also modify existing experiments because the code is just that much more simple. What can you do with SuperDuperDB? You can do quite a few things. Actually, some of the most common and powerful things that you need with AI, it helps us along the way. With SuperDuperDB, we can deploy all our AI models automatically. What this tells me is if you have a data store and you've got a bunch of users and a bunch of attributes for those users, you can pre-generate all the vectors, store those vectors in a vector store, and then leverage that data when you're creating inferences on top of that existing user data. So this helps simplify that process when you're having more of an internal look at your database directly. It allows us to assign ratings to users or assign expertise based on the data that's already been seen by the user. So it makes it simple to apply classification outputs and then store those in the database. It seamlessly makes that a lot more possible. Adding AI directly into our database is a lot easier with SuperDuperDB. What's another bonus, and I think this is a pretty foundational option, a lot of the times when we're building AI models, we don't know how successful that model is going to be. So it requires training, testing, and then validating. You have to do that over and over and over. And the great part about when you go this approach is usually you create your embeddings for your test data, your training data, all at once up front. You can store that in a database and make that really simple and seamless as you're making training on certain aspects of data. So this allows you to train a model just on specific subsets of that data, and then you can just leverage those vectors and then just off you go. You don't need to re-vectorize every single time. In most Python notebooks, even today, you'll see that the vectorization process when is in, and then also in the embedding process as is generating gradients and matrices, you're gonna see that process repeated every single time you run the model for training purposes. And so this adds a necessary reduction in compute and a nice bump in performance when you're training models. It's also nice to see that it helps integrate through code interfaces a lot with existing vendors, and I'm hoping other models that allow us to say what the embeddings are going to be and interacting with other APIs. So you can kind of think of SuperDuperDB as the glue between your database, the data there, the pre and post processing information that can be leveraged as well in your database, and then extending out into other AI vendors and AI frameworks and footprints. On top of that, they also have a vector search. The vectors are already there, so it seems like they are adding in an index as well. So as you're storing those vectors, you can also search the vectors in a nice seamless fashion. And according to all this, that vector index should also be stored in your database. So now you only have to host and run your one database just as you normally would before, and now you've added AI into it. So this is a really powerful way. Get your existing database and just add AI into it. It's a nice way to go about it, I would say. It's a nice clean way. Taking a quick look, we're gonna give SuperDuperDB a try with Handson. So we've got their GitHub repository up and running here. What we're going to do is take a look at first what their developer workflow looks like. So we've got here developer API. This is where we sit, right? We are usually in our Jupyter notebooks or we're running Python directly. We import the SuperDuperDBs, and SuperDuper makes it super easy to interface all of everything, right? We can interface directly with our database, and it takes care of our vector search embeddings, also making external API calls to third parties. So we can do some pretty powerful things. They've got some examples here of applications that we can build with SuperDuperDB and our existing database. We can do things like text-to-image search, text-to-video search. We can question the docs. We have a semantic search engine. We can do classical machine learning, and then cross-framework transfer learning. I'm not exactly sure what's going on with that one, but we can do it. They make the installation procedure fairly simple, so we just have a pip installed from PyPy. We can run that on our terminal window here. And then it says that it's going to take up about a minute to run, and yeah, I can see it's going to take a little while here. While PyPy is installing in the background, I did take a look at the cross-framework transfer learning. So with transfer learning, we have the ability to sort of add more knowledge to or fine-tune a model. And with SuperDuperDB, this is kind of interesting that we can use multiple frameworks, whether we've done this in TensorFlow probably with Keras or PyPy and PyTorch using the libtorch C library. We can communicate between the two? Okay, with the transfer learning, a cross-framework example, they're showing us the transformers, the sentence transformers, which is I believe it's what do you call that? This is one of those generative pre-trained models, for example, sentence transformer. So the cool part is we can take the sentence transformer and have the model interact directly with the downstream model in scikit-learn. That's pretty cool. I'm very much liking this. This is actually, and you wouldn't necessarily need SuperDuperDB for this particular case, though it does seem like they help and make that a little bit more streamlined and straightforward. So we're going to give it a try here. We're going to give this example the transfer learning try. We're just going to give it a test to see what happens. What we have to do first is, of course, we have to do a lot of initial. We're loading data set first. Then we split the data as usual. We'll split the data into training and validation sets here. And then when that's done, it looks like we insert the data into Mongo. All right, I was really looking to see how this could work, and how I understand it with transfer learning. What we're going to be doing is modifying existing weights, the coefficients in a model, and those matrices. We want to modify them, adjust them, or append layers to the bottom and freeze the previous layer so we can learn new things. However, I'm definitely not seeing that happen in this case, so the concept, the name transfer learning is definitely misleading in this example, though it is not off completely because from my understanding, the IMDb dataset has pre-generated AI data points that we're going to be storing inside of our Mongo database. And then what we're going to do is so we're making classification predictions on the text data field, and it says listen true, which means daemonize the model. This makes me think that it will be subscribing to a change log in Mongo, and then it's able to then run those tasks as new data is inserted into the database. It can run the model automatically for you and then append the output result. I could be off on that one, but that feels like that's what's happening based on the details described. But also we can take, here's where the transfer learning is occurring. We can take a downstream model from scikit-learn and a support vector machine. Ooh, okay. So we can create a more lightweight and more powerful scikit model that is leveraging existing trained data to create a new model that will be much faster. Then we can save that to the database and then create new predictions on it. Now, I would definitely say this is out of scope for a getting started video, and looking through all the examples they provide are fairly advanced, and I would say it would be nice to have a better onboarding experience showing like a canonical hello world from a very simplistic standpoint. Here's data in, here's data out. And then, okay, we can do a bunch of things on top of that. So they've got an example here where we can chat with our database, for example. We can pipe on, it's very likely we're going to use OpenAI here. Oh, yep, okay, we're going to be using OpenAI. We can index our data probably in Mongo, create a new vector search index, capture that index and add that data to a prompt for the AI, and then we can basically talk with our data. That's pretty straightforward, though there is a lot to it here. And I would like to see more simplified code, being that the whole promise of SuperDuperDB in general is, hey, we're going to make this whole process seamless end to end. I mean, it's good they're showing us these examples because they're really powerful, though I'm looking for simplicity. I really want simple, because it's not too far off from me generating my own vectors and my own hash bucket indexes that can be stored in a database, in my very own database, right? And I can run similarity index searches across those fairly seamlessly.